Hey guys, this is Unit 4, Lesson 3. We're going to start out with a warm-up, figuring out which solutions are equal to x times x equals 5. First one is 1 over 25. Multiply that by itself. The numerators multiply 1 times 1. You get 1 over 625. Testing out b, we get radical 5 times radical 5. We know those radicals sort of cancel each other out, and we get 5. So we know that's correct. For part C, it's 5 over 2 times 5 over 2 equals 25 over 4, right? That's equal to 6.25. So we can cross that one off as well. Part D, 5 to the power of 1/2 is the same thing as radical 5, right? And we already tested that one out in part B, so we can automatically assume that that one is correct as well. Part E, it is radical 5 over 2. I think you can take a guess here that that's going to be 5 over 4, and that is not correct. So we can cross that one off. 2. And then the last one is radical 25 times radical 25 comes out to 25, right? So that one is not correct either. So you guys might remember our favorite equation, y equals a times b to the x, which we use for exponential growth and decay problems. So I'm going to give you guys a quick reminder of the parts of this equation before we jump into an example. So remember that the A is equal to the initial amount. Be sure you jot these down in your notes. B is that rate of change, right? And if you remember exponential growth, it'll be 1 point a number, whatever that percentage increase is. And then x equals time. Now we're going to do an example using population size. Our initial population here is 54,500, talking about the state of Florida in 1840. And then we have our rate of change was 60%, so we get 1.6, right? Now time is measured in decades here, so it's 1 decade later in 1850, all right? And that comes out to 87,200. And then the next one, we just increase that exponent by 1, right? Because it's 2 decades later in 1860. Do the math real quick, and we get 139,520. Now question 2 wants us to write this equation in terms of D for decades, so we're going to do f of D equals our initial population, 54,500, times, we know our rate of change is 1.6 to the power of D. Now for this last problem, it's asking us what 0.5 means if it's in place of D. So we know that that is half of a decade, right? Which is half of 10 years, which is 5 years. Now we need to know why we can find the value of p to the 0.5 by multiplying 54,000 by radical 1.6. And we know that radical x is the same thing as x to the 1/2 power, right? And as we just talked about in this example, we have 1.6 to the power of 0.5. That represents half a decade, right? And we know that 0.5 is the same thing as 1 over 2. Now question 4 is asking for the population in the year 1858. So that is 18 years after 1840, which is the same thing as 1.8 decades. So we just write that number 1.8 into our equation in the time where time would go, right? So that's our exponent. So we have f of 1.8 equals our initial population, 54,500, times our rate of change, 1.6 to the power of 1.8 decades.